Okay, let's get going. So, hello everyone, welcome to LondonR. This is going to be the last LondonR of 2020. Hopefully we can look to meet in person next year, who knows, but it's been really great to see everybody on this kind of semi-monthly basis and have some sort of catch up with everyone. I'm Laura, by the way. I'm Mango's events and marketing coordinator, so welcome. Just a little bit about who are Mango. We were formed in 2002. We're based in Chippenham, Bristol and London, and of course at the moment various homes, children's bedrooms, everything. And we empower organisations to make informed decisions using data science and advanced analytics. And we also organise a range of data science events, so LondonR, Bristol Data Scientists, BaselR, London Data Engineers, and of course the Earl Conference, which I'm just going to come on to in a little bit. The keen-eyed amongst you may have noticed that we have a new shiny logo. We have some very exciting news. We've been recently acquired by Ascent. Ascent are a fast-growing European software services company specialising in delivering effective digital transformation. This acquisition represents an ambitious growth strategy for Mango, and it will open newly accessible markets where demand for insight and intelligence is rising. So we're really excited about this. Hopefully lots of good things to come out of it. And all the events are still going to go ahead as well. Just in terms of what Mango have been doing since COVID, for us, it's very much business as usual. We found that we've been able to, our data scientists have been able to work remotely. We can still deliver our training and our consultancy. And then on to Earl. For those of you who don't know, Earl is the enterprise applications of the R language conference. We took it online this year in October, which went really well. We had about 280 people join us on a Friday. And then next year, fingers crossed, we're really hopeful that we can meet in person. So we'll see how things go. We will be calling for abstracts in the new year. So if you have a presentation that you think might be interesting or worth sharing, start thinking about that so you can submit that. And we also already have a very special person booked for the keynote. I will say no more, and I'll leave you all to speculate on who that might be. We're very excited. If you'd like to present at a future LondonR, please drop us an email at events@mango-solutions.com. And just a kind of I feel nervous about sharing a pie chart with a group of data scientists, so don't attack me in the comments. But just kind of the variety of people and industries that we get at our meetups, as you can see, it's a huge spread. It's not particularly one massive industry that tends to dominate. So it kind of just proves that whatever industry you're from, there is something of interest and note that can be found at LondonR. And it's just good to talk to like-minded people about our stats. And then tonight we have a great agenda. So we have Gary Hutson, who will be presenting on computer vision and classification, turning a Kaggle example into a clinical decision-making tool. And then we have Gwynn, who will be presenting on faster coding, vectorizing computations in R. And then last but not least, we have Stuart, who will be presenting, I'm not going to sing this, Raindrops on Roses and Whiskers on Kittens, a few small things that make me a happy art developer. So if you're enjoying the presentations tonight, please tweet. We're at Mango the Cat, and the hashtag is hashtag LondonR. Just a few housekeeping notices from me before we get going. Just to bear in mind that this session is being recorded. I will share the recording of this tomorrow, probably. If you have any questions for the speakers, if you could just please use the Zoom chat function, and I will read those out to the speakers at the end of their presentations. And also, if you could just keep yourself on mute so things can run smoothly. I think that is everything from me. So I'm going to hand over to Gary. So Gary, if you could unmute yourself and share your screen.
Thanks, Laura. Okay. Can everyone see that screen?
Yep, all good.
Cool. Okay. So I'll take you through the process of how I envisage turning the Kaggle example into a clinical decision-making tool and the steps and the approach. So I'm using a Kaggle data set around a malaria parasite infection into cells, but this could easily be like chest x-rays, etc. So a little about me. I'm a public sector data scientist, statistician, deeper machine learner. I'm interested in all things R and Python, sacrilegious. Background in the criminal justice, council, police and National Health Service. A bit more about me there. Been coding in R for about 7 years, so got plenty of old bad practice in terms of base R versus tidyverse, and about Python for around about 3 years. I work with the NHSR community as a fellow and a blogger. I'm an ex-data scientist at a company called Draper & Dash, and we created a what we like to call kind of an Ultrix Lite for healthcare called the Data Science Platform, amongst other things. I currently work back in the NHS at a Arden and Greater East Midlands Commissioning Support Unit. We work predominantly with clinical commissioning groups and NHS England. So what is computer vision? The kind of focus that I'm going to look at today is classification, but I'll go on to examples of classification and localization and object detection in later slides. There's also something called semantic segmentation and instance segmentation. You can see for yourself what it actually does there. So, sorry, applicability to healthcare then. So in terms of how it's been deployed, there's a few examples in the UK where it's been used. One is Moorfields Eye Hospital around the detection of cataracts in looking at loads of different types of cataract scans. The one that I found linked on the internet was Mount Sinai Hospital. They're using it to detect neurological acute illness. And this has been aided by the utilization of 40,000 images. Again, still a relatively small data set for a deep learning approach, but it required a joined up approach to get those images compiled. This has led to things like more precise diagnosis. So CV algorithms, computer vision algorithms can be trained on massive amounts of data, and they can be trained to detect the slightest presence of a condition. Sometimes a human doctor might miss this out. Therefore, with clinician skill and this tool set, it can be used alongside that to actually improve diagnostic outcomes. In medical imaging, there's been increases in computer vision applications across the board, looking at the NHS X strategy and just reading some of the research. So R and computer vision then. So TensorFlow and Keras, this has aided it really, up until probably the end of 2018, before JJ Allaire wrote a wrapper to TensorFlow called Reticulate, helped to work on that package. It wasn't possible to do some of this. You had to basically learn Python if you wanted to do some of this computer vision type modeling. So the powerhouse of computer vision then, so some of you might already be aware of this, it's the convolutional neural network. So essentially what this does is it convolves over an image, so it looks at each block of an image through what's called a filter. Then it convolves that down, so it reduces that into a matrix. That process is called pooling. It does a further convolution on that pooling layer, and then it pulls it down further. Then you create what's known as a fully connected layer. This might be similar to what you're probably used to with artificial neural nets. So it starts to compute the probabilities of different types of images, etc. This is more of a complex example, but it's essentially based on the same premise that you've got these image pyramids. You create these feature maps, you do a convolution and apply filters to pick out different types of features in the image. You then pull it down and then convolve again, same process. And as you can see, you start to get quite high dimensional data. And then by the end of it, it gets reduced down through your, like you say, your densely connected layer at the end between F7 and F8. And then it generates this probability map. So whereabouts in the image, the actual probability of the actual object that you're trying to detect or the thing you're trying to classify is. This is an example of how it strides across how it convolves and strides across in a block of a 3x3. It then pulls it down, and there's a couple of types of pooling. The most predominant that I've seen are something called max and average pooling, and that's what you see in the matrix in the middle. And then essentially on the right hand side, this GIF shows you how it then actually creates the dense image. So you can see where the dense values are in the matrix. That represents where the image is. If you just get into this, I'd recommend actually picking this book up, so Deep Learning with R. I used to do a lot of my modeling in Python. but then I moved it over to on reading this book, and it's a really good buy. You won't regret it. But yeah, it's essentially by the guy at RStudio, JJ Allaire, worked with the creator of TensorFlow, Francois. I'm not going to try and pronounce the surname because my French is terrible. So building a CNN in R then. The article published on my website shows you the whole process end to end, and also provides source code for this example towards the end of the talk. But this type of model could be extended to work with multiple types of computer vision classification, X-rays, cancer scans, and other types of imaging procedures. The next few slides will show you the process of building the CNN. So first of all, your images need to be stored in a specific way for it to then be labeled correctly. So I'll show you how to do this on the following slide. I've created a couple of R functions that help you consume the data a lot better. But essentially what I'm trying to do is detect the presence of a malarial parasite versus an uninfected cell. To do that, I created an animation function, which essentially just iterates through the first 100 images, looking where the parasites occur. And it also helped me inspect the imaging dimensions as well, and whereabouts, as you can see, whereabouts the location of the parasite is in the cell. In terms of activation functions then, to build the CNN, the kind of default standard is the rectified linear unit. This solves a couple of problems. I've put links into it. I won't go into it in great depth, but it solves something called the vanishing gradient problem, whereby if you're going through a neural network in backpropagation steps, sometimes the weight increases become that small that it diminishes, and you start to lose any weight adjustments and updates. It also allows for true zero values to be outputted, so actually, hidden neurons can be turned off at will. And then in terms of the classification layer, I'm going to use the sigmoid. So you probably heard of logistic regression in machine learning or statistics. Sigmoid's based on that. It's essentially a binary classification problem. So that's the decision boundary that I need to use. In terms of this, so this is a general model structure of how you build a CNN in R. It's all got to be used with pipes, but essentially your first part of the process is to define the convolutional layer. Because this is a 2D image, I'm going to use the layer conv2D Keras function. And I'm going to apply the number of filters that I want, so the number of feature maps that I want to look at based on that previous image that we saw at the start of the presentation. The kernel size actually dictates the block that then strides over the image. I'm going to then specify the activation as relu and then just pass in the input shape. That then gets pulled down by max pooling. As I said, there's average and max pooling to that reduced matrix. Then I do another convolution over that reduced matrix, pull it down again, same process again, pull it down even smaller. And then I'm going to drop it from 32, 64, 64 to 32. Again, some of these, it's a bit of an art rather than a science in terms of the kind of convolutional architectures that you end up implementing. But like I say, in that book that I linked, there's a lot of good research about different kind of model structures. Finally, we're going to use a flattening layer. So we flatten all that all down into a one-dimensional representation. So the probabilities that can then be estimated. So what the probabilities of having a parasite or not. We're then going to use the classification boundary from the densely connected layer at the bottom. And we're going to use the sigmoid activation. We're also going to do something called adding a dropout layer to the end of the neural network. This was kind of advocated and professed by Geoffrey Hinton, who's the godfather of neural networks. On all of these little boxes that point to it, I've added links to YouTube videos and other things to watch and research. So please go into that. Next step is to actually compile the model. So we've built the skeleton of the model. We now need to compile it. Because this is a binary classification task, I'm going to use cross entropy. That links to like information theory, Shannon cross entropy, etc. if you want to look it up. Again, I've added links to the loss functionality, and it takes you through the different types of loss parameters in CNNs and deep learning. And then the optimizer to minimize the loss is specified there. Again, there's a few different types through gradient descent, etc. So I have a link to that in as well. And the metrics that we're going to try and expose through the neural net is the accuracy metrics. So in terms of how you set your data up, we're going to use a cool function in Keras called the flow images from directory. So essentially, if you get your data in the right structure, so a training test or a training validation subdirectory, you then put subdirectories in the bottom. So whatever you're trying to classify, in my instance, it's parasite and uninfected. I'd have 2 subdirectories in either test or train to do that. Keris then will assign it kind of a 1 hot encode. So it will say in alphabetical order, weirdly, parasite will probably be given the 0 label and uninfected will be given a label of 1. In terms of then the data generation, because we want to rescale it between probabilities of 0 and 1, we have to rescale it in the image data generator at the top. That's then repeated for the test data generator. We indicate a batch size, so the number of batches we want to process through the neural network. We're going to use the function flow images from directory to create those class labels for us automatically, specify the input shape. This is then replicated for the test generator. And the classification mode is obviously a binary classification problem. We're then going to fit the model. We're going to use the number of steps for each epoch to go through the network. We're going to use the number of epochs, so 50 complete passes through the whole training data set. And the same thing happens with the validation or test data. Finally, the process is to create a baseline model. We're going to serialize the model output. It's a Python object, so it needs to be saved as a H5. And then R's got functionality to read that in through Reticulate. As you can see, my first baseline model wasn't performing very well, so I needed to improve it. It's about 50% accurate. Might as well just go home at this point. So what I've done to improve it then. So there's something called data augmentation to improve your models. So what I ended up doing is creating synthetic augmentations of the images that I previously had. So here, the big win for me was to apply a zoom to the actual parasite images. So go in by about 80%. Because obviously I saw that some of the images were some of the parasites were quite small when we were actually viewing the data in something novel like Microsoft Paint. We zoomed in and found that it was about 80%. It started to really detect the boundaries of the parasite. And we're going to rescale it as well at that point. But that then augments on top of the existing images to actually improve the number of images you've got to train on. Additionally, I've added a few more steps to my network architecture. So I've gone a bit deeper in terms of the number of feature maps that I've added. That's highlighted in blue. I've flattened that out to a one-dimensional matrix, and then I've added a very kind of deep, densely connected layer to look at all the interactions between the probabilities to make that classification. Done the same thing with the sigmoid, and then I've added a dropout at the end. So fit augmented model then. A couple of things around neural networks, especially CNNs, they're prone to overfitting. So one of the strategies is to add a dropout layer. Another strategy is to add something called early stopping. So early stopping, as you can see in the callbacks argument in the fit generator section, you can call back early stopping, and you can monitor I think it's the validation accuracy that I was monitoring at that time. And I've set the patience to wait 5 epochs before it terminates. So essentially it says if the validation loss starts to, like you say, become greater than the training loss, then you've got some issues there with it overfitting. After that, it's just a case of waiting. After I've built my network, it's about an hour and a half on a GPU because it's processing images, so it takes quite a long time. On a CPU, probably 4 to 5 hours waiting for it to terminate. Once I've completed that, I'm starting to get a lot better results than previously. It's going up to around about 70% on my 8th epoch. Averaged out was around about 67% accurate. Again, it can be improved further, and there's steps that I'll advocate in the next slide to actually further improve this. I've I only built the model for about an hour and then got called away on another project. So yeah, there's a lot more that can be done with it. So in terms of then using the model in practice, so we've got this serialized model stored into memory. We can then pick that up, and suppose we've got then a new sample that's been passed to us. This could be a new chest X-ray, some kind of diagnostic imaging, etc. I'm going to treat the 100th index of my trained parasite, so the 100th image, as my new sample. I'm going to use the image load functionality to load that image in. I'm going to set the target size. So the initial input target size was 130 high by 130 wide. I'm going to specify the image to array, so it actually creates an array of those values. And then I'm going to reshape that array based on the actual dimensions of the predicted image. And then I'm going to add a vector. I'm going to say I've got one new sample, and then I'm going to specify the image shape. So the image shape is a vector of 3. So it'll be 130 height, 130 width, and the number of color channels. So in this case, it's 3, because it's an RGB color scheme. Finally, I'm going to convert the newly created tensor that I've got there, that I've created, because it's got 4 dimensions. I'm going to rescale it by 255, which is the number of pixels. Finally, I plot that out as a raster, and it gives you the image on the right. I mean, this is not going to really benefit the clinician with one example, but suppose you've got thousands of new scans that you need to process and help then classify. That's where it's going to become a real benefit. Finally, what we're going to do is predict the class of the image. So I use the predict model function, and then I'm going to use the image tensor to make that prediction. So it'll predict the probabilities of which class it belongs to. I'm going to use the Keras predict classes function as well to predict the model from that image tensor, then pipe it through as a data frame. Then I'm going to add some simple deployer just to convert, because I said previously that Keras does it, encodes it through how it sees the directories in alphabetical order through the flow from directory. It needs to then be re-encoded. So I'd want my parasite class to be 1, but in this case it's encoded as a 0. So what I'm going to do is set the parasite class label to, if it's 0, then it's a parasite class, otherwise it's uninfected. Then just do some simple renaming and bind it all back together. And then that forms this this prediction on the right-hand side. And as you can see that that's got a parasite that's invaded it, and it's predicting with high probability that there's a parasite in that cell. So further model improvements then. So the problem I had here is there's no pre-trained networks available for this kind of data set. There's things like the image nets. So you might have seen the popular cats versus dogs classification scenario with convolutional neural networks. Again, the image net dataset contains millions upon millions of images from Google. However, there's no such thing for the NHS in terms of imaging datasets. So when I did a similar presentation to this, I had this as a call to arms to NHS bodies to link up and have these scans available, so we can start making these clinician aiding tools or decision-making augmentation tools. Another way to do it, so improve the model, I could use different model architectures. So there's a couple of papers around different model architectures in terms of CNNs. So one called ResNet, MobileNet, ResNet 50, the Inception network. Again, these are all linked in the book that I showed you. There's also other implementations if you have a look around in the Python kind of libraries as well. In terms of this, in saying this, as of today, hitherto, transformer networks are now becoming the new trend. So they're in the space of natural language processing at the moment. But there's a kind of a paper that's been just published around how it can now replace convolutional neural networks. So watch this space. I've linked it in there in case you're interested in that. Further ways that I could improve it would be further imaging adjustments, scaling, a bit more augmentation, or simply just getting more scan images, and that would be done through this collective joined up approach as I've already advocated. So where are the downfalls of R versus in terms of CV then? So R works great when it comes to classification. It can do some of the facial recognition stuff with the video play R, but it's not got the libraries like OpenCV as well implemented in R as in Python, albeit I don't know how to use them in R than I do in Python. So yeah, there's other ways that you could use Python to actually enhance it. And that brings me nicely onto my next point. In January, the NHSR community is going to run a Reticulate webinar, so feel free to sign up for that. Follow my Twitter feed at StatsGary. Like I say, I'll post it on when it's available. But essentially then you could knit all that together quite nicely using Reticulate and TensorFlow and start making object detection solutions as well. So a novel example of classification and localization it would be drawing a bounding box around a face. So using this is an example of a face mask detector. So you could train the the faces that don't have face masks versus the ones that don't, and that could be augmented essentially. But this is how you then apply it to video. Again, this is Python code, unfortunately, but hopefully one day we could bring it into R. But as you can see, the bounding box detects whereabouts my face is. And as you can see, when the face mask comes on, it's down now detecting the probability of me wearing a face mask versus not. Again, this is just a fun solution that I came up with. But this is essentially how that classification solution could be applied into live video streams. On the next slide, there's also our happy team at Mango. We could basically go, right, let's detect all the faces in this image through object detection, drawing bounding boxes. It uses an architecture, so a pre-trained network called YOLO, called You Only Look Once. Then it will highlight the features in the faces, so it detects where the eyes and the nose and the mouth, actually, the mouth begins and ends. We could then use this to then extract all the faces in that image, and then put that through another classification task. So I could then say, on the front row in the blue jumper, is that Matt Aldridge from Mango, etc., or Laura potentially in the green? Is that right, Laura? And then you could classify it that way, and then come up with a detection algorithm whereby if Laura walks into a room, I don't know, you know that she's there, etc. Fun examples of how it could be applied. Okay. That's me, rattle through it in the time. Hopefully there's enough time for questions, Laura.
Oh, that was brilliant. Thank you very much, Gary. Does this mean I can't commit any crimes if you can recognize my face?
You can tell I used to work for the police as well, can't you?
Well, just give everyone a minute to type questions if they've got any. Julia Clark asked, could you post the link to the paper on the chat, please?
Yeah, I'll put the link in the actual presentation.
Okay.
I'll link all the code as well.
Okay, great. Matt Aldridge says, are you getting me and Matt mixed up? Lucas asks, how's the GPU support in our environment at the moment?
It's good because it's using the TensorFlow backend. So as long as your graphics card's got CUDA in it and enabled and it works right, there's a bit of a jiggery poker with TensorFlow to actually get it to work. But as long as the DLLs are installed, it works just as the way as it would in Python, so it's fine.
Great, thank you. Just see if anyone else has any questions. If you're panicking typing, I'm not sure. When do you have to leave, Gary?
I've got to go very shortly, around about 5:05, but I can answer these in an email afterwards.
Sure, no worries. Patrick, I will send out the presentations tomorrow. So Gary, are you okay to send me a copy of your presentation and the code, and I can send it out to everybody
after this? Yeah.
Great, thank you. Okay, I think that looks like everything. Thanks again, Gary. That was brilliant.
Thank you. Yeah, I enjoyed it.
Cheers. Okay, so next up we have Gwynn. So Gary, if you'd like to unshare your screen, and then Gwynn, if you'd like to unmute yourself, and then once Gary's screen's gone, if you'd like to share yours.
Here we go. Can you see it?
Yes, all good.
Okay, and you can hear me?
Yeah, all good.
Okay, perfect. Hi, I'm Dr. Gwynn Sturdevant. I work at Laboratory for Innovation Science at Harvard Business School right now. And I'm really looking forward to giving you this presentation about vectorizing computations in R. So just a little bit about me. I did my PhD at the University of Auckland, which is the birthplace of R. It's actually where it was invented. And so I learned, and I think I was first introduced to R in the year 2000, many years ago, but I decided I wasn't going to learn it. And then eventually I went back and did my PhD, and I learned it. Oh, actually it was 2001, my mistake. And so, no, 2002. So anyway, I'm just going to talk to you a little bit about how we can speed computations up in R and do things a little faster. Ooh. Let's see if I can get this to run. There we go. So I gave a little bit of a presentation about this at USAR 2020 that just passed. And the problem that I was addressing was that I had this sample, and I was trying to estimate the population mean with the sample using the bootstrap. And I wrote some tidyverse coding, and it was taking a really, really long time. And so I thought, oh my goodness, I really want to spend time, on the presentation, not on the computations. And so I vectorized the coding and it ran much, much faster. In fact, I looked at this and it runs between 8 and 10 times faster. It was just amazing how much quicker it ran. And, you know, it was kind of, I was really, really surprised. So from then I've been thinking, gosh, you know, vectorizing coding, which is something that I learned ages ago, is something that I think is really important, something I don't think we speak enough about in the R community. The other thing I want to point out to you here about this coding is that this is much more traditional, the way that we deal with, you know, I don't know if you've taken, you know, algebra classes where you have a composition of functions where they go from the inside to the out. And I think you probably saw in Gary's talk, in the tidyverse, we often do one function and then we do the next function and then we do the other function. So it's kind of reading it the way that we read words, as opposed to this kind of inside out computation, which is much more, I think, for me, the way that I was taught when I did math. So it's just a different kind of way to do this. And this will come up again later in my talk. And so I wanted to point it out here. Okay, so when should you vectorize coding? So we're talking about vectorizing coding, which means that you're not going to be taking something out of the box. You're going to be writing it all yourself. And this is a really, I like to vectorize coding all the time, which is something that, you know, makes things longer to do. But this chart says, basically the take home message is, if you don't do it that often or that frequently, probably don't spend a lot of time on it. It's better to just, you know, what's the word? You know, to let it be as opposed to focusing on it a lot. The problem I'm going to talk about now was something that I was doing a lot of, and so I did need to spend a lot of time on vectorizing it. So I'm not sure if you came across this tweet from Elon Musk, but so Elon Musk was complaining he had taken these rapid antigen tests, and he took 4 of them in one day. 2 were positive and 2 were negative. And so what these rapid antigen tests exchange is they exchange accuracy for speed, right? So it's less accurate, but it's faster. And of course, the PCR test, this is the COVID test, the PCR test takes 24 hours, but it's much more accurate. So there's this trade-off between accuracy and speed. And sometimes there are other measurements that are not very accurate as well. For example, blood pressure fluctuates a lot, high cholesterol levels, as well as fasting blood glucose, which is used to determine when someone has diabetes. So if we have a noisy measurement, but we're wanting to figure out, we have a lot of error, but we're wanting to figure out a time to an event, time to death, or time to some kind of event, there's ways to do that involve, you know, statistics and modeling. This is one method, and it's survival analysis, and this is discrete survival analysis here with this portion, this portion, and this portion, and then I add on this capital gamma I, which is has to do with the phi there has to do with specificity, and also this this delta ITI, which has to do with both specificity and sensitivity. So we're having multiple measurements, multiple testings done, but what we're interested in is time to an event, perhaps death, and then we're interested in this beta here. This beta is what we're wanting to estimate. You know, we've perhaps run some kind of trial and we want to know, does the treatment make a difference or not? And so I'm going to be talking about how to vectorize this function here, actually the derivative of this function with respect to gamma naught L, but which you may want to use to actually make the coding a little faster. So if you're trying to optimize coding, sometimes you can put in the function, the derivative itself, and get the coding to run even a little bit more quicker. Right, so it's kind of messy. This is a very messy function. And so one of the things that I recommend doing before you begin to code anything is to simplify as much as you can. So you want to find some simplicity within this coding. So let's look at this again. And what I saw, or what we saw when we looked at it for a very long time, is that this is repeated in several places. So we call it the hazard risk function, and we repeat it in a number of places. And then at the bottom here, it's actually the complement of the hazard risk function in this line here. So what we're able to do is to simplify this a lot. So it's not so much for us to look at. And it's also, this also has to do with the function composition that I was talking about earlier, where you go from inside to out, so on and so forth. So this is a good substitution that we can make that has some kind of simplicity, that we add some kind of simplicity to it. Nonetheless, though, this is still quite complicated. So what we're going to try to find is a little bit of clarity about exactly what's going on with this function. And I'm going to go through that right now. So for example, if we let ti observed, so in this case, in these functions, we are going to have ti observed, which is the observed value, which may be different from ti, which is the actual value. So there's kind of two different variables that we're dealing with. We have ti observed, which is the actual value, and then ti observed, which is the observed value and the actual value, but those may or may not be the same because there's this measurement, this error. So here we go. So I have this one here. I'm just gonna go through this little portion first because it's, looks like the simplest. So j goes from 1 to 5. So that just means that this gamma naught, this j here, goes from 1 to 5. So we can update this, and we see here this 1, 2, 3, 4, and then 5. And then what we have left is this function here. And the reason it's important for you to understand this function is so that you can understand how I vectorized it. So it's really important because the derivative is kind of a similar computation. So if k is 1, we have k goes from 1 to 5. So if k is 1, this becomes j goes from 1 to 0, so it just becomes 1. And then I end up with this, the complement of the hazard risk function evaluated at where k is 1, which is this, right? So if k is 2, I'm going to end up with j goes from 1 to 2. I'm sorry, 1 to 1. And then I'll have this hazard risk function evaluated at gamma naught 1 times the complement evaluated at where k is 2. So I'll have this. As you can see, this just grows. It grows and grows, and we end up with 3 and then 5. So we have kind of these products and then something at the end. So now let's talk a little bit about the derivative of this function with respect to one of the gamma naughts. And this isn't a derivative taking. I'm not trying to teach derivative taking here. I just want, so I'm not going to go through this with a lot of very thoroughly, but I just want you to see for this first portion here, this top line, if I'm taking the derivative with respect to gamma naught 1 or gamma naught 2, that the rest of the function is constant. So I only need to take the derivative with respect to whatever gamma I'm wanting to take the derivative of. I'm not sure if that made sense, but I think you can see it here. So it's just this product of all the other ones and then whatever L I choose. Now, I'm not going to go through the rest of this computation. I don't think it adds very much. So let's move on. So the first thing I'm going to talk about is indexing, and normally in base R or we do a lot of, you may use for loops or something like that. And when you first see this function here, which was the calculation that we do to take into account any kind of measurement error, you'll see that this is, we're multiplying a number of the specificity measurements here from 1 to ti observed minus 1. And then di observed, either di observed is either 1 or 0. So we either have the phi of ti observed or 1 minus phi of ti observed. So one of these two will go away. Okay, so how can we think about what we're doing and what we're accomplishing here? So I'm just going to go through a quick example here. So we have this fee. I've made it from 0.8 to 1. And then we have TI observed and we have DI. I'm sorry. Yes, DI observed or T observed or D observed. So if I have this here, so I have T observed, TI observed is 2, then this is just gonna be from 1 to 1. So I'm just multiplying by this one. And then I have D observed is 0. So it's going to be times, it's gonna be phi of the 2, which is the TI observed here. So I'm just gonna multiply these two numbers, right? Does everyone understand that? Does anyone have any questions about that one? If you do, it would be a good time to ask. I hope that's clear. So if we have 5, so for example, we have that TI is 5, I'm gonna multiply these first 4 ones together. And then for this sample, all of these are 0. So then it's going to be times 1 at the end. Okay. So what I'm doing is I'm multiplying a whole bunch of them together to make up this product at the first. And then I have these things at the end. Now, you may think, oh, for loops is a way to run this or so on or some other way. But I'm here to talk to you a little bit about indexing in a way that's vectorized. So what I've done is I have this matrix that I call lots of fees, and it's I have 5 TI observed here, and so I have 5 columns and I have 5 fees, so there's 5 of those as well. But for each person or each value of TI observed, I'm going to have 1, and then what I have is these this matrix of I's, which are all of these. In fact, I could call it J, but you know, it's all of these values here, right? From 1 to TI minus 1, right? So the idea is that I'm going to try to replace, because what I want to do is find this product here first. I'm going to try to replace some of these with 1, and the ones that I'm going to replace with 1, for example, here, this goes from 1 to 1. So I want to replace all of these with 1. This one is from 1 to 4. So I'm going to replace, well, this one's already 1. And this one I'm going to replace for the, you know, the third one is also going to be this one 1. And this one is going to be all of them are 1, right? And then I can take the product of the columns, of the rows. I can take the product across the rows, and I've done this whole computation, I've done this whole computation in one big chunk, which is what's really important. It's trying to do all this computation in one big chunk. So if I do this, I index off of this one. So for the values that are less than T observed or greater than T observed, greater than or equal to, they become 1, right? So that's the computation, and that's how I'm doing it. And that this is the coding that does that. So the key point here is to see this, lots of phi, and then I have for lots of I that are greater than or equal to 0, I just turn them into 1, and I end up with this computation here. I've turned them all into 1s, and then I can apply a product, and then I have phi to the T0, phi at time T0 to the power 1 minus D0 times 1 minus phi at time T0 to the D0, right? So one of those is going to go away, and I've done my computation, and it's vectorized, and it will run much, much quicker than if I'm trying to do a for loop or any other kind of method, okay? So the next coding I'm going to talk to you about, this one's a little bit more complicated. It involves both phi and theta. So both sensitivity and specificity. And this part here, I think is pretty clear how to get it from the last example that I gave you. So you just do the exact same thing, except for instead of TO, you put in TI. So this is the actual value. It's kind of the unknown value that we don't know. And then we're going to be dealing with this TI to T observed, the TI observed, right? So the first thing I'm going to do is go through an example, and let's look closely here. So the first one I have, so the first one is T0, the TI. So the observed time and the actual time are the same. So I'm going to have multiply these two, and then this number is going to go away, right? And then because from TI to TI, it doesn't make any sense for it to go to 3 to 2, and then I multiply it by D0, D observed is 0. So I'm going to multiply it by 1 minus this one here, 0.05. So it's this times 1 minus theta at 3, which is 0.05. Okay. The next one is also TI observed is also 3. So I'm going to multiply by these two. But this time we don't observe whatever it is that we're looking for till the 5th time point. So we'll multiply by these two here, and then just this point off the end, one of these at the end. So this one is, I think, pretty clear how to get because it's exactly the same as the other one. But this one, there's a little bit more, it's a little bit more involved. So we have to think carefully about how we can index it to get both, smush it from both ways so that we have both. So it's greater than TI and less than TI minus 1, right? And that's the product that we want. It's kind of these middle values that go through in this matrix here. So for this one here, we're going to go from TI to, the first one, of course, we don't have anything here. So this whole thing should be 1, right? That's what we want. We're going to replace it, all of it with 1. The second one here, it's going to be from 3 to TI observed 3 or 4. So it's going to be these two that we need here, and all the rest of them need to be 1. And so that's what we do here. All of these are 1, and then these two are 1 here. And then for this one, we have 2 between 2 and 5, right? So it's 2 and 4, between 2 and 4 we need to find the product of those, right? So what we've done is kind of created this matrix that now, once again, we can go through and take the product of the rows, and that will give us this value here. And so that it's very similar to what we did earlier, except for that instead of having, just 1, we're just indexing it off of 1 number. We're saying it's either less than this or greater than or equal to this, and then it's 1, and then we've gotten the right values that we want. Okay, so the other thing I want us to pay attention to, I'm going to talk briefly about a new function, which is the outer function. And what the outer function does is you put in a, because I'm going to use this next, you put in some kind of function, whatever it is, and then you have y and x, and using this y and x, it uses every combination of the y and the x and does this operation to it. So so for example, this one is 3 to the power of 2. And this one I'm sure would be 8 to the power of 9. Okay. Right. So, and that's another thing that you need to think about carefully when we vectorize coding, is that there's lots of what's the word, matrices that we have to deal with, and we have to make sure that we're dealing with we have an awareness of what the dimensions of that matrix are. Okay, so now we're going to talk a little bit about that inside out stuff, which is often the way that algebra is done. And this is the derivative of the function. And I think that we've done a number of the building blocks already for us to be prepared to vectorize this function. If you look here, we're doing the product of this horrible thing, this hazard rate function, and then we're taking the derivative with respect to the hazard risk function. And I'll show you what that is later. So this first part here, I'm just going to go through maybe a little bit quicker. We have this hazard risk function right here. And I just put in some values for beta and some values for gamma. And I had some X's. Oops, excuse me, my mistake. I hate, oh, there we go. Some values for X's, some values for the X's. And we have X beta, which is, you know, I'm going from the out to the out in. And then I have the risk, which is, and I've rounded it to 2 because it gives me too many decimal places, which is one thing I really like from the tidyverse, is that it doesn't do that quite so much. And then I find this, this B matrix using the outer function, which takes this risk to the hazard, hazard to the risks, and it takes Y to the negative X, and it creates this for me. So now I have a matrix of these, and I just have to multiply them. Right? And then here's the derivative of this horrible function with respect to gamma naught L. And I have this B outer to the risk, the hazard risk function that I've created. And then I have the derivative. And then all I have to do is take B, and I take off the column that has of the gamma that I'm taking the derivative with respect to. I take the product and I multiply it by the derivative. And that's the whole first part. So when you first look at this, you might think, oh my goodness, this is a whole bunch of for loops. It's really messy. But I want you to see that it's, you know, what, 7 lines of coding in R. So it's really, really powerful to be able to do something so simple with all these computations. So the next thing is just a little bit more complicated, because we have this added this here, and we also have this product up to. So right, this is going to also be quite similar. What I have here is I'm making the all the HRs, and then I've made the derivative, and then I have this product up to which gamma. So this is going to give me a whole bunch of these. This is going to give me the B's, all the B's. And then what I do is I make a matrix of all of these B's, right? So I have B, and then I have B again, and then I have it again, and then I have it again, right? So it's going on top of each other. And then I replace this A with those that are less than which gamma plus 1 and greater than T0 with 0, and I just add it together. So it looks like it can be a complicated, horrible thing, but if you are able to vectorize computations in R, they can run much more quickly. I mean, they may not have the ease of reading that tidyverse coding has, but I think that there is still value in being able to run this quite quickly. I just wanted to mention here that that they updated Magritter, I think, yesterday, and I'm not sure how that impacts upon how much quicker it runs, but fingers crossed. Okay, so this is all I have to say, is avoid for loops and do calculations in big chunks wherever possible, and you may be able to speed up your coding a whole lot. So thank you so much for coming. Let me escape. Oh, let me stop my share. There we go.
Thank you. We've got a question already from Lars, who asks, can the vectorization process itself be automated? Are there any tools to help?
There aren't. You just have to use your brain. I'm really sorry. You just have to use your brain. I have to be honest with you, that's my favorite part of R, is getting to vectorize the coding, because it's such a different way of thinking about it. And R is the only language that has that capability where you can vectorize things and run them really, really quickly. So there isn't a way to automate it besides thinking very carefully about it. And I'll just tell you the truth. I did my PhD at the University of Auckland, the birthplace of R. And there's a class there that you take. And if you have for loops in your code, you can't get the best mark possible, even if it's the same answer for someone who did a vectorized code, who vectorized the coding, right? It's you have to learn to vectorize coding, otherwise the coding runs too slow and it takes too long. So there isn't anything. You just have to think about it, and you have to get used to thinking that way and indexing in a different way. I spoke to, I don't know if any of you identify who Ross Ihaka is. I spoke to him about this on Friday night, and Ross Ihaka, does anyone know who he is? I don't know if anyone knows who he is. Someone knows who he is. I'm so happy. Okay. Anyway, so Ross Ihaka invented R with Robert Gentleman in the 1990s at University of Auckland. Ross Ihaka was Hadley Wickham's master supervisor. But anyway, so I was just talking to him on Friday night, and he said vectorizing coding, and I asked him that exact question, like, how do you teach people how to do it? What do you do? And he said, it's just like doing back handsprings through a burning hoop. And of course, so it's still something you have to learn. It's still something difficult that you have to learn, and it's a really challenging thing. But I'll tell you that I think it's the most fun part of coding in R, is trying to figure out how do you vectorize it so that it runs quickly, and how do you get all the dimensions around. And I just think it's really interesting. So don't be like me. Don't do it all the time, because it doesn't it takes a lot of time, and it can be really creative. But I don't know. I hope that answered your question, and I'm sorry, and I know it's a kind of an ugly thing to vectorize, but I just thought, I think it shows how powerful the dealing with that is, because it can be so much more simpler than doing that. Anyway, thank you.
Thank you very much, Gwen. I think that's all the questions. So yeah, cheers. Thanks a lot. So last but not least, we have Stuart Lodge. So Stuart, if you're there, if you could unmute yourself and share your screen.
Working on it. Hopefully that's done something.
Yeah, we can see your presentation now.
Cool. Can you see yourselves? I'll try and get rid of that.
Yeah, I can see you.
So yeah, I'm a developer, and there'll be a lot less maths than there was in the previous talk. Well, I know we have a reputation for being grumpy developers, so sorry about that. But I thought I'd try and share some of the ways that in the last few years, moving across from C++ and C# and JavaScript and all the other languages across to R, some of the little things I found to make me happy. So it's not going to be the deepest talk of the day. And yeah, I'm quite childish, so very easy things make me happy. And there are ways to make developers happy. You can throw money at them. We always like having bigger machines and more RAM and some graphics processors and all sorts of things. You can throw libraries at us. R has some amazing libraries. And it really makes us more productive. And when we're productive, we are a lot happier. But what I thought I'd talk about just today is just to share some of the smaller things, some of the marginal gains I found, and some of the things that have made me more productive, just in particular in using RStudio, and just at that kind of editor and IDE level. So that's enough of PowerPoint, particularly enough of PowerPoint. And I just thought I'd talk through some little things that just, through years of using Windows, in particular, although Mac is very similar as well, and through using IDEs and using editors, just little things. And I hope some of it may be of use to some of you. It's definitely at a different level to the previous talks, but variety is hopefully good. So just, in terms of editing, I'm sure I hope all of you are used to typing, know how to type and to select words, to do Control-Shift-Right in order to select things, and just shift some characters to select individual things. And I'm sure all of you know how to cut and copy and paste. So I know, you know, cut is Control X, paste is Control V, those sorts of things. But recently in Windows, we've been very lucky that finally we've got multiple paste as well. So you've got a paste history. So if you use Windows and V, then you get access to the last sort of 10, 15 things that you've got in your clipboard, which is very useful when you do actually want to pick up, you know, perhaps you want to pick up just 4, and you want to pick up empty cars, and you want to pick up filter, and you copy all those things, and then you can paste them. But you can also go into the history and choose what it is you want to paste from that history. There is also recently in Windows an emoji keyboard that's been added that's very useful for when you want to add those comments that include a love heart or whatever. However, the bad news is I'm afraid that RStudio, unlike other editors at the moment, doesn't support that. So it's a bit of a shame. One of the other things that I've picked up and I've never used anywhere else, but I have used in RStudio, is selecting using Control Shift and Up. And I don't know who uses this or if anyone does, but Control Shift and Up is just wonderful. And if you're inside like a string and you select by doing Control Shift and Up, it selects the whole of the inside of that string. If you go again, it selects the quotes. Go again, it'll select the parameter name. Go again, it selects all of that, and it just keeps going up. So if you've got you know, curly braces and a function, it'll just keep going up inside those things. And Control Shift down goes the other way. So if you're editing code and you want to move things around very quickly, you want to copy and paste certain sections, I really, really like that Control Shift Up and Control Shift Down just as navigating around code. One other thing that you'll certainly notice if you're a Windows user is that RStudio's got a little quirk that when you type something and you undo, Control Z is normal, but Control Y, that is a normal redo thing in Windows, is actually a Control Shift Z for some reason in RStudio. So, you know, these are just useful things. I'm sure most of you knew all of that probably beforehand. Other things that you pick up very quickly and you want to know is stuff like the find functionality and the multi-cursor functionality. So if you are, you want to find the next between, if you double click it to select that and then do a Control F3, then that'll take it up to the find dialog. And then after that, F3 will find your next one, and Shift F3 will find your previous one. So that's all very useful when you quickly want to find something. So again, if it's margin 2020, Control F3 and then Shift F3, F3 will let you find the next one. There's also this interesting button All, which I don't think I've seen in any other IDEs. It's not something that normally happens. And if you hit that, what you actually get is you get like all of the instances of margin 2020 selected with this thing called a multi-cursor. So you can see wherever this is in the file, it's selected. And if you start typing, it actually will replace all of those things across the entire file. So it's a really easy, quick way to replace Trump with Biden or whatever else you might want to do across your file. Yeah, there are other ways to get this this multi-cursor up. By the way, once you've got a multi-cursor, to get out of it, do the escape to get out of it. There are other ways to get that up. One of them, let me just get some white space over here, is to use Control and Alt. And then wherever you click, once you've got Control and Alt, you'll have a new multi-cursor. So wherever you want to, you can then type the magic programming words of foo. That may not seem immediately useful to you, but if ever you do have, that you'd like to insert on this line, let's get that again, Control Alt, this line, and this line, you'd like to insert, a different word very quickly, you can do that using this multiple cursor. And it's particularly if you've ever pasted in from Excel or somewhere else lots of data, then it's quite often that you want to put a column in which case the Alt, the Shift, so if you get the cursor in the right place and Alt Shift select, then you can select a column very quickly and get multi-cursor in just to edit things fast, because fast is productive and we just want to do this as quickly as possible. As I said, this is a talk at a very different level to the talks previous about all sorts of computation, but I hope some of those things are useful. There's one other thing in this multi-cursor that you can also do that's quite useful, which is this, I'm sure everybody's used to Control Shift M. Is it Control Shift M? It's all muscle memory to get your Magritte pipe out. But if you add an Alt to that fixture, and what you can actually do is get to a rename, and it renames within scope. So if you've created a function like this load of election results function, and you just want to rename this parameter, then a control shift alt and M will allow you to do that renaming. So, you know, perhaps you wanted to call this file path all along. And you'll notice that was really done in scope. It didn't affect the paths on the outside. So, you know, that sort of refactoring tool is really common in things like Java and C#. And it's great to have some of it available in R. There are attempts in RStudio also to do a few other things. So if you look up here, there are some extract function and extract variable. I found they don't work particularly well in RStudio, sadly, but hopefully we'll see more of that in the future, because those sorts of things really do make it quite exciting to be a developer. It's quite fast and productive. Intellisense, moving through, because I'm aware that I'll talk for far too long if I'm allowed, so let's just keep the pace high. I'm sure that all of you, you know, use Intellisense in code completion all the time. So as you type mutate, then you pull up, you know, what is it you'd like to complete that with? Perhaps it's mutate each or whatever, and you're used to that. If you'd like to pull that up early at any stage, you know, perhaps you just know it's a new word, then control space will pull that up. And it's quite useful just to know that you can get that Intellisense. And also, if for whatever reason you close that Intellisense, you know, escape, you can pull it back up again using control space. Another thing that's useful in that Intellisense in RStudio is that if you are, you know, doing a path thing again and you've got a string, then actually control space, once you're inside a string, starts pulling up the files and the folders from your working folder. So in that case, you can go, right, I'd like data tab, I'd like that folder, and I'd like that file, please. And it's a lot quicker than remembering what that path is and doing it. So just having that control space option within quotes really does make me happy that I don't have to type those things out longhand. Cool. Spinning through as quickly as I can, keep going. F1. I'm sure all of you have used F1 to get hold of help. So, you know, if you're on install packages and you hit F1, then over here in your help viewer, you'll get the help for F1. F2 is also really quite useful. F2 takes you either, in the case of a package file like install packages, it will take you to a decompiled source for install packages, for example. Let's just go to a mutate. If I could type, it would help in my job. If you do an F2, that takes you, I'm not going to mutate in that one because it's a re-exported, but generally it will take you to the source of the function. If you are in your own function, like here, it's a local one and you do F2, it takes you to where you define that function, which is really useful as a quick way of navigating around your code. Because quite often you're changing something, you want to go to the function, then you want to go back to where you called it. All of us are used to browsers and back functionality. In RStudio, that back functionality is Control and F9. It's a really fast way of browsing through your code. Control F9 takes you back, and Control F10 takes you forwards. Yeah, so Control F9 and Control F10 really are useful things to do. F2, as well as taking you into a function definition, like with load LX there, if you do have a data frame loaded locally, like for example here we've got LX, I think it's a data frame, so you can see, you know, it's a tibble locally. If you're in that and you hit F2, it'll quickly pull up the view for it. Which again, you know, it's not always useful to get a view in this style, but it's nice to be able to get to that data quickly if you want to, and perhaps also without having to use the mouse or go down to the console or type view. And again, once you're in there, Control F9 takes you back to where you started. So all of those things are really great, quick ways for getting between bits of your code. And as a developer, you know, quite often when you're in the flow, it's nice to be able to navigate really quickly between things. One other thing in navigating there is the period functions, the control period and the control shift period. Starting with control shift period, which is perhaps not the most useful. Control shift period takes you up to this little chevron. So if you're down here and you type control shift period, it allows you to see the files you've got open, and then you can choose which one, or you can start typing that it's installed and you want to go to this one. Control period is a much more powerful search, and it also does fuzzy matching, whereas that control shift dot just does the start of the string matching. So control period will look in your current space and will either take you to a file or function. So let's say that we're in here and I'd like to go to my big let's find a function that actually exists I'm sure I've got something called function, I always do. So, you know, there's an example function I'd like to go to. It'll find it for you, and it does fuzzy matching within there. This is particularly useful if you're working like a package and all of your functions are across different files. It's really fast to be able to go, well, I'd like to go to my example function, see what's there, perhaps edit a few things, Control F9 back to the script where you're testing out those functions. That for navigating around is really fast and really fluid way of getting around. It gets you over the barrier of like only being able to see so much of the thing you're currently editing. It's like a new dimension into your coding, makes me a lot happier. Continuing forwards, reformatting. So quite often you want to comment out code. I'm sure most of you already know that you can comment out blocks of code using Control Shift and C. And you can comment them back in again using Control Shift and C again. It's a really useful thing to do. If you ever are writing comments, it's nice to write, you know, really long comments. You know, 52 words is never enough. 42 words is never enough. But obviously, to read that, you're now over in column, you know, 204 or whatever here. It's not so useful for people to read. There is a shortcut which is Control Shift and /, which will automatically turn that into a nicer format of comments. And again, if you start editing in the middle of it, so again, you start making it too long for whatever reason, then again, just another Control Shift / and it will reformat it down to a format that will fit on those lines for you. So it's nice to have those tools for when you are starting to make, you know, longer things across there. You just got to write those comments in there. If you are fortunate enough to work with some mathematical people as well, you may discover occasionally they pass code across to you that looks a bit like this, and it's quite hard to read. You know, it's the same code as we saw above about the functions, but for whatever reason they've chosen to you know, not space it out because they've just been typing and trying to get the maths right, or trying to get the presentation right of the data and not of the code. You know, as a developer, as somebody who's been developing since the 90s, I've been brought up on code complete. I've been brought up on that sort of really care about your code, really make sure things are working well, and look nice and are easy to read and easy to scan. But if you get given something like this, there are ways of just reformatting it very quickly. So, you know, if you come across and you use Control Shift up again to select the whole of the function, then there's a shortcut which is Control Shift A, which will take hold of that code and do its best to format it. You'll see that, you know, whilst it has done some good stuff, it's spread everything out so it's a bit more readable, everything's in columns. It still hasn't quite got some of the spacing right. It's put mutate a bit inconsistently about where it starts. There's some other ways of doing reformatting as well, including there's a styler add-in that you can use. And that styler add-in, available from the add-ins menu up here, allows you to style by selection. So here I've added the style by selection. It'll go off. You'll see in the console that, you know, it's actually using something called Tidyverse style, which is, you know, maintained by the Tidyverse team, and it now has tidied up some of those problems like mutates. So, you know, if you get files sent to you, whatever, and you want to quickly format them, then a Control Shift A followed by a style really does sort out most of those problems. Yeah, and now that code is kind of more available for you to edit and understand a bit quickly. That's all there is really on those, but I hope those are very useful. Other things, console. So, I mean, we're all used to this REPL environment in R, and it really is a nice environment to be able to you know, type whatever it is, empty cars, and see it down in the console. If you ever need to navigate down to the console and back again, rather than reaching for the mouse, there's a really handy shortcut, which is Control-2, which will suddenly get you down there. And there's a really easy way to get back, which is Control-1. If you are on like a restricted laptop, like I am at the moment, a restricted screen size, there's also a nice way of zooming your display so you don't, you know, you get a bit more real estate to focus on what you're doing, which is Control-Shift-1. And when you're in Control-Shift-1 in the zoomed mode, you just get what your current context is. So here, you know, I'm just in the editor. If I wanted to go back and just be in the console, Control-2 will get me down there. There are also Control-3, Control-4, Control-5 shortcuts, which will get you to other bits, but those are the two that I actually remember, because those are the only ones I really care about. While you're in the console, other things you can do, Control L will clear it for you. So you get rid of all that junk, perhaps after you've got something you want to focus on where you are. Escape will clear whatever you've got in there. So it's quite handy just to clear your current line. Up will take you through what you've recently been typing. So it's quite useful. If you know that what you're typing is something to do with MT cars, but you can't quite remember what it is you ran 10 minutes ago or yesterday, then a Control Up will take you to recent things that you've run in the console. So it's really useful. That uses the history within your current project. So, you know, it's project dependent, but it's a useful way of saying, oh, that was the one I wanted. I wanted to find out, you know, which cars have got 6 cylinders. Useful little tips, I hope. Again, many of you, I hope, know, you know, lots of these already. Get out of Zoom, just do a Control-Shift-1 again, and you're back where you were. Control-1 back into the editor. Also, as I guess you already know, Control-Enter runs things. Alt-Enter is slightly different. It runs things but doesn't move the current cursor. So it's quite handy if you are just repeating things over and over again. Perhaps if you've, done a path to some string, then you can run Alt-Enter. Then you can do Control-Shift to select. You can run Alt-Enter again just to check it's in there without quite so many movements of the cursor, etc. Snippets, another thing I really love. I guess, again, lots of you know snippets are there, and lots of you, perhaps use them. Snippets are, you'll notice in the code completion, if you do something like an if and do Control Space to bring it up, you'll see the first option there it's got a different icon, a little bit like text, and it says it's a snippet. And it tells you also in the yellow pop-up there, it tells you what it does if you select it. So if you tab in to select it, you get an if statement and you get the condition highlighted. If on its own probably isn't the most useful snippet in the world, but there are other things in there, like if you quickly want a Shiny app, the Shiny app snippet, which will do that. It's really good if you're doing demos, because you can pre-cache, the bulk of the code you want to type, and just have the useful bits that you need to fill in live for the demo. And the snippets themselves, on Windows, they're in this directory. On Mac, it'll be somewhere in your home directory in RStudio as well. Or you can get to the file using global options, code, and it's here, it's edit snippets. And you'll see you've got snippets for every type of language you might want to be playing with in RStudio. And the format for snippets is here as well. Let me just edit those in the editor rather than that, because it's a bit easy. So if I do a Control, Shift, and Dot, then I know I've got my snippets open here. So a snippet, just looks like one of these. It's just got a simple bit of a keyword of snippet. This is a LondonR snippet. Perhaps you would like a $1 name. It's important this is a tab. Yeah, that's how it works. It's on tab indenting. And then you might have a foo dash is going to be back in the $1 color name. Important you have the dollar though. So if you add as many snippets as you want, perhaps they're for logging, perhaps they're for messaging, perhaps they're for SQL, like the example I've got there. It's quite a useful thing to have in your armory for bits of code that you want to be typing frequently, but that you don't want to put into a package, because every time there's little changes you need to make from it. Once you've done that, back in here, what did I call it? I called it LondonR, should be available as a snippet. And if you just change name, it'll change. So I quite like snippets. They're very handy to do. If you're developing a package as well, it's pretty easy and straightforward to put those snippets into the package, and then whoever installs your package gets those snippets for free. So if there are common ways of writing your code, that's a great way of doing it, using your package. Cool. On to exciting new things. I don't know if any of you, most of you, all of you are using the preview version 1.4 of RStudio, but if you're not, I highly recommend it, because one of the things they've introduced in this preview version is then called a command palette. If you've used like Visual Studio Code, you'll know what that is. It is just the most fantastic thing for making you productive and wonderful. So essentially, everything I've been saying so far is like you need to know about Control and Shift and Alt and what to do with your right knee and all sorts of things to get these operations to occur, and you run out. You just can't remember all of these special combinations. And there's only so many things that can start with the letter Z or whatever that you need to use. And you can see the scope of the problems by actually pulling up the keyboard short. This is the quick reference. It's not such a quick reference when you're in here and looking at it. And you can edit those as well. Somewhere on Tools, Modify Keyboard. You can keep adding things. But like all of these ones without any lines, any shortcuts next to them, they're just blank at the moment, so they're a bit like hanging. But this is where Control-Shift-P comes in. So with Control-Shift-P, when you hit Control-Shift and P, up comes this command palette, and it's got lots of commands that you might typically want to do while you're editing the file. So perhaps you want to create a new R script. You can select that to create a new R script. Perhaps you wanted, again, if we go back up and find the ugly code. Where was the ugly code? When we were looking at the ugly code and we selected it, perhaps you wanted to run that styler. What you can do is start typing styler. What is it you want to do? I'd like to style the selection. It's so much faster to do that and so much easier to remember how to do it than it is to go to that add-ins menu, scroll to the bottom and find things. So that's why I really like this Control-Shift-P. It gives you access to commands. It helps you discover commands because you're in there and you're thinking, well, what is it I want to do? It's something to do with knitting. It's that sort of thing that you can do very quickly without having to remember Control-Shift-K, all of those sorts of things. Highly recommend it. It's out there in the preview of RStudio, and obviously the preview will become the release fairly soon, I guess. Magic, really like it. That's what Control-Shift-P. It's possibly the thing I use most now in RStudio in terms of these accelerators, these things to move me through my code quickly. Also, while we're talking there, obviously you saw for add-ins, you saw the styler plugin, and the styler is one example. If you ever want to create your own add-in, they're pretty easy to do and they're coded in R. All you have to do is create a function like that, and then there's a little bit of DCF Debian control format, command format file, which is just that text format like you get in packages. And it's just a function like that. So if you do want to create your own add-ins, you can. There's also a directory of add-ins. If you search for add-ins list, you'll find that directory. Or obviously, if you do Control-Shift and you'd say, I'd like to find how many add-ins there are, add-ins, there's a browse add-ins, and that'll pull up, here's the directory of add-ins, and these are the things which are available locally, plus there's links to external ones. So it's pretty handy to have. And some of the things you can do in add-ins, I mean, obviously you've seen like, an insert example here. There are other things you can do. For example, there is a clipart add-in that I use. And clipart allows you to take something and either put the output to a clipboard or its value to a clipboard. So here, LX was like my data frame. I use value to clipboard. If I now go to something like an Excel window and paste it, I've got the data really quickly without having to write some code to, write to a CSV and then mess around in Excel. It doesn't work for like nested data frames and a few little things, but overall, it's a really fast way of getting that data into the clipboard and then across into Notepad++ or Excel or anything else. So I really like that. For a bit more ambitious of what you can do, if you take a look at like a ggplot, like you run this one, that's a standard example of a ggplot. But there's a plugin that you can get to again, Control-Shift-P, that will allow you to GG theme assist. And if you run that, what it does is it inline, it opens up a little Shiny app. And that Shiny app then gives you access to ways of styling it. So, perhaps you want to change the panel background. Well, it's not doing so well on the screen share. You want to change it to a green background. Perhaps you want to know how to change these things to dashed lines or dotted lines. Perhaps you want to add some titles or my first chart to it. These are things that you can obviously look up how to do. They're not, impossible things to do. They're things which are out there on the web or in, R for data science or whatever. But it's a quick way of saying, you know, I'd like to remember, I can't quite remember, how do I put, you know, these titles or whatever at 90 degrees. That's not a good looking chart. I'm going to use 30 degrees. How do I put that at 30 degrees? How do I create alpha or whatever on any of these things? It's just a nice, easy way of styling the chart. It obviously looks a bit better when you're not sharing your screen at 1080 or whatever it is that I'm sharing at the moment. But you know, it does that. When you hit done, it goes back and creates the right code for you. So then you can go in and edit the fine details again. And obviously it remembers that if you go back into GG Theme Assist again a second time in order to see what's in there. So that's the sort of thing you can do if you start getting excited about how you're going to you know, generate these charts, generate these add-ins. And really it's quite a interesting area that I'm getting more and more into all the time. So that's quite exciting. The last thing on my list of things that are making me happy is really stuff that's not actually in RStudio, but is in other places. So recently I've been dabbling like in the dark arts outside of RStudio. And I've been looking at things like IntelliJ and things like VS Code. IntelliJ is made by JetBrains. As a C# developer, like in the last few years, there's a product called ReSharper that JetBrains make, which is just fantastic for doing, it really just changes the way you code altogether. And IntelliJ, which I've got open down the bottom here, feels very similar. Just if you are typing in IntelliJ, obviously, you know, it's another development environment. It's got your normal sort of R displays over here of packages, a viewer, documentation, and plots. It's got a console window. It's got this sort of environment / debugger / watch window that you're used to. You can view tables just as you can in R, but it feels really snappy as an environment. Unlike RStudio, which is all HTML and JavaScript based, this is like written either in Rust or C# or C++ or Java or something. It's a faster environment to code in. And when you type in here, it really does show. It feels faster. You get, you know, a bit more responsiveness. It's also got some of those refactoring tools. So, you know, in here, I'm lucky I can find out how to refactor these things, refactor, rename. And it's got those sorts of things that you expect as a developer. I really do rate this quite highly as an environment, and I'm enjoying it more and more. It's also got the advantage of being free. This is IntelliJ Community Edition, and the plugin is open source as well. Where it lacks, it does lack a little in some of the Shiny and Markdown so far. I found it's still got support for them. It's just not quite the specialized, quite, you know, the oomph that RStudio have been putting into them. But overall, it is a quite delightful environment to code in, and you know, it feels responsive when you execute things. This console window flies by with the information in it, so I really quite like that. I've also been playing in VS Code, and VS Code is, you know, again, it's a really good development environment. It's a really good IDE. It's used and it has become very popular in the last 5-6 years. It doesn't have great R support though. There are a few different ways of getting R in there, and it does work. Like, you know, everything here is being plotted. This is via something called an HTTP graphics device. It does have a console window where, you know, again, if you are typing away, it'll give you that. It can have a small debugger. However, overall, it is also lacking a few things. Like it's definitely easy enough. I can't draw the map in here, it crashes. And it's got a few other small quirks, which means it's not quite as delightful to use at the moment as RStudio and as IntelliJ. So it's one to watch. The instructions that are on the blog by rankin.me are really good and easy to follow. And if you want to get involved in an open source project, I think it is a platform for the future. So I think, you know, as an editor, it's really great. And I think it will have the opportunity to be better and better and better. One of the things that's interesting here is the console output. And, you know, if you're used to R, then you're probably used sometimes to using an R terminal that looks like this. You know, it's just a DOS prompt, as it were. And, you know, you can type in here MT cars, I mean, certainly you can't use Control-Shift-M or whatever and get things back, but it hasn't got, you know, some of the help that you get from other consoles and from other development environments. The console inside Visual Studio Code, the instructions point you towards something called Radian, and Radian is a Python-based platform which provides this R prompt. Again, it's a DOS command window or Bash window if you're more Linuxy, and in here you get a little bit more in terms of Intellisense. So I quite like the NT card, the Radian approach. It also has some ways to come out of R mode and into sort of more DOS mode or Linux mode if you're on Linux. So I quite like that as an approach. So Radian's worth looking at as well. Right, those are things which make me happy. I think I've covered a fair amount there inside half an hour. I didn't talk about other things. Obviously, you can also write R in Jupyter, and Google Colab has that for free. And I'm kind of hopeful that GitHub Codespaces will also have that for free when it comes through. GitHub Codespaces will be based on Visual Studio Code as well. And there are other Jupyter environments where you can just go in and use the R. So back to PowerPoint, finish off. There are some really good things out there, some really exciting things which make me more productive at that kind of keyboard I/O level. There are also all those libraries and all the goodness which is R and its vectorization and its data frames. Yeah, that was me. I'm more of a developer. I'm working currently in an asset manager called Orbis, but nothing I've said today counts as financial advice, please note. And yeah, that was a lightning tour of some things that made me happy.
Great, thank you very much, Stuart. We've got a question from Julia. She asks, does the shortcut for inserting a chunk in R Markdown work in Windows yet?
I don't know, doesn't it? File. Right, so we would go to a new Markdown, create a new R Markdown, and then we want to insert a chunk. Code chunk or R chunk, or I think that works.
So what's the shortcut for it then? Because I haven't got the.
So it's saying Control-Alt-I for a new code chunk.
I've tried Control-Alt-I and it's done nothing.
I would guess to debug that, you could go to modify keyboard shortcuts and find out what it's Control-Alt-I. How do I use this to get to Control-Alt-I? What am I looking for? Insert chunk, maybe.
Mm.
Does yours say Control-Alt-I? Do you have a clash on it?
I haven't got it open now, but that's what it's supposed to be, I think. That's what I've tried before.
So it's definitely working for me here, like Control-Alt-I. If it's not working for you, find out if it clashes with anything. I know, for example, that I've got a Control-Alt. So another way of doing multi-cursor is to do Control-Alt and up and down. But for me, what that does is rotates the entire screen, so it's not a good thing to do.
It could be different versions of RStudio.
Yeah.
The IDE.
All right. So yeah.
But yeah, it could also be that it's overridden at the operating system level somehow. Control-Alt-I. Don't know.
I've got another question. Not specifically R or RStudio, but what is the tool that is displaying in the control sequences that you're doing, that you are redoing in large text in the top right of your screen?
Oh, so the thing that's showing like Control, Shift, and P up the top. That's there are a few of them around, but that's a program called Karnak Keys. Yeah, Karnak Keys. And it's just a way of helping people understand what it is that I'm typing. So it's just set. You can choose which programs it does and things. It's just a little tool on Windows that allows you to show what keys you've pressed. Yeah, you can do it for all keys if you want. So if I uncheck that, then suddenly you'll discover everything I type is got there. But in general, you just want it for Control-Shift type sequences. Yeah, so Carmack keys. It's freeware. I presume the developers won't mind if you buy them a beer as well.
Okay, great. Are there any more questions? We will send out the presentations. Stuart, are you okay to send me a copy of your presentation? I can share it tomorrow.
Yes, there's not a lot in it, but yes.
Okay. Someone asked for the links that you used.
I can share the file, I guess. Yes.
Okay.
These links, just these, or?
I'm not sure which particular links, but
we'll work it out anyway. It's easy enough.
okay. Okay, great. I think that's all the questions. Thanks again, Stuart. That was brilliant.
Thank you.
Okay, everyone. So that's us done for LondonR for 2020. Thank you for joining us. I'll send out a recording of this session tomorrow and also the slides from all the presenters. If you've enjoyed LondonR this year, let us know. We're at Mango the Cat and the hashtag is #LondonR. We'd love to hear from you. Presentations you've enjoyed, things you want to hear about next year. I think we'll be back in January, probably most definitely online, but yeah, I will let you all know. So yeah, thank you for joining us and see you then. Bye.